Welcome to Archiversity online lectures. In this lecture, I am going to show you how to calculate chi-square test using Microsoft Excel. In Microsoft Excel, you don't have any direct formula or a function or a method to calculate a chi-square test. From the data collected, you need to draw a pivot table to get the observed frequencies. Using observed frequencies, you need to calculate expected frequencies and then you need to run a chi-square test. Now I'll demonstrate that for you. A retail outlet store which runs multiple retail outlets in Hyderabad city wish to know that whether they are able to cater the needs of a different categories of a customers. That means according to customers whether they are able to get all the products available for them or not. For this purpose they conducted a survey and I am taking a simple extracts of that. So from questionnaires we use the family size, that is whether it is a nuclear family or a joint family. The family size has multiple options, that is the family size is 1 to 2 members in a family, 3 to 4, 5 to 6 and above 6 members in a family. Then these respondents are asked a question on how broad is the product range available at this store. That means whether the product range is extremely broad which caters all their needs, very broad, moderately and not at all a broad. That means they are not able to get the products that they wish. So for this purpose, as these two variables are categorical and measured on one is on a nominal scale and one is on a ordinal scale, what is that we do is we'll run a chi-square test. Chi-square test is performed on categorical data. So how is it we are going to perform a chi-square test is, here is the formulas for a chi-square test. That is chi-square value or a chi-square test value is observed frequency minus expected frequency upon expected frequency, and expected frequency you will get as a row total times column total upon a grand total, and the degrees of freedom is number of rows minus 1 times number of columns minus 1. Here is the data. Alright, now what is it we are doing is we want to run the relationship between family size and the product range. So instead of selecting all the data set, we select only these two, that is selecting the family size and product range. Now once you select this, then click insert, then click a pivot table and choose new worksheet, click OK. Now you find the pivot table fields here. So what you do is first drag the family size to the rows box, then product range to the columns box, then once again product range to values box. So now you have a observed frequencies table here. Now copy this one and paste here. Now you see here extremely broad, moderate, not at all, slightly, very good, very broad. But very broad should be the second column. What is that you need to do is select the column K and then right click, insert. A blank column is inserted here. Now select O where a very broad category is there. Simply drag this to empty column here. Now this is perfect, moderately. Then a slightly broad should be here. So select the column M and drag this onto the right of the slightly broad and delete this one. So now we have a observed frequencies in order: extremely broad, very broad, moderately broad, slightly broad, not at all, and grand total. So this is a row total. So we name this as a row total, and here this is a column total. And why column total is because this total is sum of these three values. So these are observed frequencies. Now using these observed frequencies we calculate expected. Our expected frequencies, the formula is row total times column total upon grand total. So we'll copy this table. We name this as family size here. Now copy this and paste. Delete the data because we need to calculate the counts. So to calculate the count, this here, this equals to your row total is here times column total upon grand total. Now press enter key. Now you got a expected frequency and drag this. So you got an error message. Similarly, try onto the right side also. You got an error message. Why you are getting this error message is Excel, when you drag the equations or formulas, it will automatically cascade. Then in the sense, it takes the values from the next cell or next row or column. Now to know that, just click this cell and click on the formula and observe the cells here. Instead of 206, that is a J8, Excel selected J9 because when you drag it downward, it took the next cell. Similarly here also. And now look at this one and click on the formulas. Now you see, instead of column O, when you drag on to the right, it took a column P. Now how is that we are going to avoid this? In the sense, to avoid this, you need to instruct Excel that a particular column and row should be constant as well as a particular cell also. In this case, we want column O should be the constant. So first column O here, and you insert a dollar symbol in front of column O, so that Excel understands that even you drag onto the right side, your column O should be constant. Then we want a row 8 to be constant. So we go here and in front of a row number, insert a dollar symbol. So this makes Excel to understand that a particular row should be constant. When you drag down also, it will not move to the next row. It will in the same row, that is a row 8. Then finally, to get a grand total, you want to keep this particular cell constant. That means row and column both should be constant. So insert a dollar symbol in front of a column as well as in front of a row. So when you insert dollar symbol in front of a column and a row, that means you are making a particular cell constant. Now drag to the downside and drag on to the right. Now you have a expected frequency. Now once you have observed frequency and expected frequency, then you can get the chi-square value, or that is a chi-square p-value, with the help of Excel built-in function. To get a chi-square power value, this equal to chi. So here you find different chi-square distribution functions. Now these functions which are having a dot extended one, these are available in Excel 2010 onwards. Earlier versions, that is Excel 2003 or 2007, have these functions, that is a chi-dist, chi-inverse and chi-test. As we are performing chi-square test, so double click on a chi-square test. Then it prompts you to give input for actual range. So here is your actual range. Don't select the row total and column total. You have to select only the observed frequencies. Place comma, then expected range. Close the bracket, press enter key. Now you have a chi-square power value. The power value is 0.39. This power value will compare with our significance level. Let us say you want to test it at a 5% significance level. That means 0.05. Now we will compare calculated power value with significance value, and if calculated power value is greater than significance value, then we accept null hypothesis. Now what does null hypothesis indicate? The null hypothesis indicates that the customer's expectation, that is the availability of product range, is independent. That means based on the family size, each category of customers, they have a different opinion on availability of a product size. That means somebody may be saying that they have a available product range. Others may say that they are not getting a available product range. So that is a null hypothesis. Next is to get a chi-square value, chi-square table value or a chi-square value. Then here use function equals to chi-inverse. So double click on chi-inverse. Then the probability, that is your p-value, comma, degrees of freedom. So how is that we are going to calculate degrees of freedom? This is number of rows minus 1 times number of columns minus 1. Here we have a 3 rows That means 3 minus 1 is 2, and 5 columns, 5 minus 1 is 4. So 2 into 4 is 8. Then close the bracket, enter. So your chi-square test value is 8.369. So the lower the chi-square test mean acceptance of null hypothesis. This is how you need to calculate chi-square test using Microsoft Excel. Thank you for watching the lecture.